Good afternoon, everyone, and welcome. Before we begin, there's just a few housekeeping items we need to discuss. So turn on your chat for ongoing commentary. Use the Q&A. We're going to be using the Q&A function to submit questions. And your mics are muted by default. To verbally ask a question, raise your hand using the raise hand button or just submit a Q&A request. Now I'm going to turn it over to our moderator, Dr. Mike Hunter.
All right, well, welcome to everybody to Research Data and the Future of ITS. We've got a great set of presentations today. We have University of Maryland CATT Lab. We're going to hear from Atlanta DOT's big data approach, mobile data collection system, also corridor management of the future. This is going to be a fantastic set of presentations on data, and I'm really looking forward to it. But before that, we're going to have a reading from the 2011 time capsule from Carla Holmes.
Hello, ITS Georgia 2020. I hope that you are continuing to be leaders in ITS. Georgia has been doing great things in ITS since before the 1996 Olympics, and even now, in 2011, we are still leading the country in the depth and breadth of our ITS program. Navigator rules. So best wishes. I hope your future is bright. I hope you're still making a difference in keeping Georgia's roads safer and more efficient. And I hope I'm still around as an elder statesman. Good luck. Wow, that brought back so many memories. Thank you so much for allowing me to be a part of the 2020 ITS Georgia Annual Conference. Great job in remembering to open the time capsule, and great job in remembering that we even had a time capsule. I've worked with Tom Seaver as co-chair of the 2011 ITS Georgia Annual Conference. And back then we were at the fabulous Ritz-Carlton Lodge at Reynolds Plantation. Our theme then was 2020 Vision, seeing into the future of ITS. We got a lot right, but no one could have predicted how 2020 has actually turned out. Who could know that most of us would be attending a virtual 2020 ITS Georgia Annual Conference from the comfort of our own homes? Many of us having been working from home for 6 months now. I'm sure good luck with COVID-19 wasn't in anyone's time capsule letters. How could we have predicted the tremendous impact a global pandemic would have on our personal and professional lives in 2020? I mean, really, who could ever believe that you could possibly travel through Atlanta on a weekday morning without encountering any rush hour traffic? Would have been unheard of in 2011. But what we did get right was that ITS Georgia continues to be at the forefront, not only in ITS, but also in the broader arena of transportation systems, management, and operations. Our local, regional, and state public sector agencies in Georgia continue to raise the bar with innovative programs and projects that not only to address today's needs, but also position them better to meet the challenges of the future. And they are supported by vendors and consultants who have the tools and techniques to continue to keep Georgia at the leading edge of innovation. As a former board member, I am so proud of ITS Georgia. It's nice to see familiar faces of those who continue to contribute to the organization. Our 2020 annual conference chair, Dino Pampolina, was actually our AV committee chair back in 2011. I remember how do we engage young people used to be a constant theme at our board meetings. I'm so pleased to see so many sharp younger generation professionals who have picked up the torch and are leading this organization and continuing it to thrive. I'm absolutely thrilled that we also now have a student chapter at Georgia Tech. That's awesome. I'm so proud that the organization not only continues to keep our technological edge, but we also have fostered our social consciousness by things like helping disadvantaged students through our digital learning support program. I'm excited about what the future beyond 2020 holds for our industry and for the people that we serve. Things like connected and automated vehicles, big data, smart cities, active mobility, sustainability, resiliency, and the importance of operations. All those things are going to be major factors in how well we address the challenges of the future. And I'm so looking forward to what we're going to learn at this conference, and so happy to be a part of your 2020 annual conference. Thank you.
Okay, well, thank you, Carla. That was fantastic. Before we start our first speaker, quick note that we're going to hold questions till the end. We'll do all the questions in, but feel free to put them in the chat box on the side as we go, and then we'll just kind of start addressing them near the end. So with no further ado, our first speaker is Michael Pack, who is the director of the CATT laboratory at the University of Maryland, where he works with his team of 75 professional software developers to make data more readily accessible and usable. He has previously worked at the Oak Ridge National Laboratory and the University of Virginia. Take it away, Michael.
Thank you very much, Other Michael. So today I'm going to be talking to you all about some things that I envision for the future and things that I think that we should be looking out for as professionals in this field that would make us all better suited to meet the challenges of today and whatever's going to come our way tomorrow. And of course, my specialty in the CATT lab is really all things data. And of course, data is here. It's been here for a while, and more is coming. There's literally trillions of daily transportation measurements that are coming from the traditional ITS sensors that we've deployed, including your ATS-PM technology that you've deployed down in Georgia, and emerging connected autonomous vehicles technology as well. And that includes transit data, first responder CAD, and all that sort of stuff. But how are we as agencies really going to know what's available and effectively integrate all this data into our operations and planning groups and avoid getting burned by particularly bad contract terms or overhyped and underperforming technologies? And then how can we build or leverage open and trustworthy tools and technology? These are all challenges that we've faced in the past and are going to face moving forward as well. And I frequently hear people touting the benefits of data, and I completely agree with that. But data alone isn't the answer. If all we focus on is data and collecting data, then we're kind of going to overwhelm everyone in our industry. So we really need to help with policy guidance and tools and technology and R&D and other types of thought leadership that's going to help to reduce the anxiety with respect to working with this flood of data that's coming our way. And I really feel strongly that agencies need to continue to invest as much in tools as they do in data, tools that make it really easy to work with different types of data sets, because data is really only useful to us when it's easily accessible and understandable. Otherwise, it's just sitting on someone's computer someplace and they're the only ones that know how to work with it. We want to be the ones who can work with all of us. So to be effective, I believe that every agency first needs data, which we all have plenty of, and that can be really anything. But then we need those tools, and those tools are things that are going to fuse data together and derive statistics and integrate things. But you also need analysis and visualization tools that help you to actually see what's going on in the data. And then, of course, you need domain expertise, you all, the people that can actually understand what's going on with the data and the systems. And once you have all those things together, then your agency can start to derive some insights from the data that you're collecting. And when it comes to deriving insights and communicating, it's really less about just presenting data back to people, and it's more about storytelling. So we should never, ever think of our jobs as just presenting data. If we just present data, we're not really doing our customer service. Instead, we need to be focused on telling stories with the data that we have in our midst. And there's this whole concept of data-driven journalism that a lot of agencies are starting to lead towards. And that's where you have data first, you do some sort of cleaning, you structure that data, And then you filter out the noise, the junk that doesn't make any sense. You get down to that relevant information. Then you have to focus on visualizing it. And those are generally simple charts and graphs or some other form of compelling imagery that can make your point. And then once you've got all that, then you start to tell your story and convey a message that is going to be clear and concise to whatever your target audience is. And the way in which you tell that story is going to be different if it's internal engineers and planners versus the public and legislators and whatnot. But this whole concept of data-driven journalism and telling stories is something we all need to learn to embrace, and that's really going to raise our value to the public. So other things that I think we need to focus on from an agency standpoint is our policies with respect to data and other things. Our policies are really lagging, and we have to get on them now if we're going to be able to keep up with the future. So I don't know how many of you were involved, 15, 20 years ago, back when traffic.com was going out, and we were allowing them to install their sensors on our right of way, on our roadway. And that was a service that we were allowing the company to have, but then they were selling their data back to us. That was a bad policy decision. We also allow lots of companies to come in and install fiber along our right of ways. And then in return, we only request maybe 2 or 3 strands of that fiber. We're giving away too much, in my opinion, when we allow people to install things on our right of way. But now we have the connected and autonomous vehicle revolution hitting us. There are millions and millions of connected vehicles in Atlanta alone, and all those vehicles have sensors on them. They're telling you things about when people are braking, or when the windshield wipers are on, or traction control getting engaged, or even when the airbag gets deployed. So the question is, who's going to own this data? Is it going to be the vehicle manufacturers? Is it going to be the telecommunications equipment folks? Or are we as a DOT going to start thinking about putting policies in place that say, if you're going to be allowed to operate your vehicle on my roadway, I want you to provide some basic level of information back to me so that I can understand what's happening and do a better job of managing the roadway for you and planning for the future. And if we don't start making some policies now related to this, it's going to be too late, and we will never be able to get access to that data. Or if we do, we'll have to write the biggest check you could ever think of. Other things we need to be planning for is our technical capacity. Most DOTs have lots of program managers and engineers with them, which is what a DOT should traditionally have, but we need to invest in other technical capacity for managing data and doing a data analysis. And it's not fair to expect our transportation engineers to do this stuff alone. We should also be looking at hiring other skill sets and then teaching those other skill sets about transportation and collaboratively working together. So those other skill sets are data scientists, analysts, data journalists. Consultants can do this too for us, but all too often in our industry, we go out and we hire a consulting firm to come in and do a very specific thing with a very specific set of data for us. We hire them, they do their job, and we fire them, and we move on. And when we do that, we've lost all the investment in that consultant, all the education that they've gained in working with that data and working with us. We really need to train our staff and transfer that knowledge, or think longer term about having really long-term contracts with these consultants to help us out, so we don't just hire and fire them and lose all that knowledge. And also we can partner with universities or other similar institutions. That's one thing that the CATT lab does frequently, and every state has a university that can do this sort of data analysis for them. And of course, invest in research as well. Other things I'd warn agencies about is beware of distractions and hype. Man, there are so many buzzwords and shiny objects out there right now. We have people always coming into our agency trying to sell us things. Everyone's heard of blockchain, machine learning, artificial intelligence, business intelligence, the cloud, agile. What do these words mean? If they're just used in a marketing pitch by someone, we need to empower ourselves to learn what these words mean and be able to cut through the BS that sometimes comes through from our well-intentioned partners. So please take the time to educate yourself and learn what these mean. Don't confuse them, and understand their relevance to your particular project. If you're building a new road, do you really need someone to come in and sell you blockchain? Probably not. And don't think that just because a company throws out these words that they're going to solve all of your problems. So let's talk a little bit more about technology, buzzwords, and hype. Many of you have probably seen this hype cycle, technology hype cycle thing that Gartner puts out every year. The bottom axis of this graph is time. The y-axis is expectations. What you have is you've got some sort of innovation trigger that comes along and people start to get excited about a new technology, whether it's artificial intelligence or something else. And then you eventually reach this thing called the peak of inflated expectations. That's as high as anyone can ever think this technology could possibly achieve. And then over time, you start to kind of come back to reality, and you have what's called the trough of disillusionment, where you kind of swing in the opposite direction. You say, wait a minute, this technology was nonsense. We never should have invested any money in it. And then as time progresses, you have something called the slope of enlightenment, where everyone starts to realize, the technology wasn't as great as we thought it was going to be. It's not as bad as we thought it's going to be. It's really something in the middle. And eventually you have the plateau of productivity, where you reach the maximum gains you're ever going to get from that particular technology. So this is the actual hype cycle from 2019. And what you'll notice on it is you have a lot of things that we're hearing about today: artificial intelligence, neural networks, blockchain, IoT platforms. They're still relatively early in their days, and we're not really sure where these technologies are gonna fall in the realm of usefulness as we move forward. So just be aware of these things as you're moving forward. The cloud is one of those technologies that gets overhyped over and over and over again. The cloud is extremely cost effective for agencies when you do things the way that the cloud company wants you to do them. But don't necessarily assume that the cloud is going to save you money or improve your capabilities all the time. Sometimes it will, sometimes it won't. And you don't necessarily have to be in the cloud to be effective or innovative. And the cloud shouldn't be used for everything. It's not an all or nothing thing, and not all clouds are created equally. And some people use virtualization and cloud interchangeably. They're not the same thing. We as an agency who are dealing with more data now need to know the difference between these different technologies and these terms. And one of the most often ill-used terms is open. The word open in front of anything: open data, open source, open space, open standards. They're not all the same thing. And just throwing the word open in front of a technology or another word doesn't necessarily make it right. So we often confuse open source and open data, and we often make big institutional investments based on a misunderstanding of what open data versus open source is. And we don't understand the impacts of having open source contracts versus open data contracts. Open source typically applies to software applications, whereas open data simply applies to data. And there's a big difference between the two, and you can hurt yourself if you don't know the difference. So what are some innovations that are about to come out that I'm particularly excited about and we all need to be aware of? It's really getting into non-infrastructure based data collection. Now, I give Georgia all due credit for being the absolute leader in the nation for deploying ATSPM. It's fantastic. You've had the budget to do that. You've done it better than anyone else I know. Not every state has the wherewithal to be able to do that. And so there are all sorts of companies now that are able to deploy ITS without infrastructure, being able to collect ATS-PM-like data without actually having to install any equipment out in the field, doing it just through tapping into these connected vehicles data streams that third parties now have. There's some amazing things that can be done with that, and a lot of other agencies around the country are starting to look at that. Same things goes with just understanding people movement, being able to track where people are moving around the country. That can all be done now with connected vehicles data streams that exist. In fact, the University of Maryland is doing that right now. Many of you may have seen our COVID-19 Insights platform, where we're actually going out and looking at connected vehicles data streams and data streams from mobile devices like cell phones and iPads and other things. And we're literally able to go in and tell how many people are out moving about and how many of them are driving versus flying versus on a train versus on a bus versus biking or walking. And we've turned that into a free and open impact analysis platform that everyone in the country can get access to. And you can see your state, your county, how many people are going to work, how many people are staying home, how far people are driving every day. And all that's being done without installing any sort of ITS infrastructure at all. It's just using data sources that are available commercially. We're also seeing a big push in multimodal integration. So tying together what's going on at an airport with what's going on with bus routes and transit and at terminals, port terminals where you've got cargo coming in, and tying all these modes together with the highway mode as well, so that you can actually see how impacts to one mode are affecting the other mode. And Maryland has just invested a lot of money in some multimodal performance measures investments. So my predictions for the future here is data isn't going to get any smaller. We're going to have more and more of it, and deploying infrastructure is likely going to become increasingly less necessary for many agencies. It's important for us to get our house in order, or else the latest and greatest technology that comes out won't matter if we're not ready for it and we don't have the skill sets in our agency to be able to handle these data streams. Tools should make a lot of this easier. So think about Tableau. Tableau is really becoming the new Excel. So if you've known Excel, now you need to learn Tableau, and something will eventually replace Tableau in the future as well as our new data visualization analysis tools. But as expectations change, so do the skill sets we need to have. So everyone's expectations are going up and expecting us to be able to do more things, and we really need to invest together and pool our resources for some of these data analysis and management tools. So my last slide here relates to that. Back in the 1800s, the National Weather Service was put together because it was recognized that weather data was critical to public safety and the economy, and it was put under the Department of Commerce eventually. Well, our transportation system is just as critical to the US economy, if not more so. And our transportation system is fragmented. There's no single agency that has a complete picture of the system. And this has implications for safety, security, and quality of life. And I believe strongly that we as an industry need to follow the National Weather Service model and develop the equivalent of a national transportation service, where we collect all the transportation data in the country, standardize it, put it together into one location so that we can start to answer some of our critical transportation infrastructure questions and get back to realizing how important transportation is. So that's my prediction. Those are the things I think we need to invest in the future. And I appreciate you taking the time listening to me today.
All right, Michael, thank you so much. I know we're going to probably be losing you here at some point, so I want to give you one quick question before you go, and then we'll be jumping to our next speaker. But one question that was asked was, can you share some success stories from other agencies about how convincing the management about hiring data analysts and how you compete to gain and keep them?
Oh man, competing to gain and keep them. I'll answer that one first because that's easier. There are an amazing group of people out there that just care passionately about transportation. If you create a position in your agency that is transportation, data analysis, and visualization, you will find a swarm of passionate people that don't actually care about working for Silicon Valley companies or Department of Defense, that just want to have a positive impact. This is the social justice generation. So you've got people that are going to be willing to come and work for you if you give them tough problems to work on. Now, as far as convincing your management, man, I think if your management don't believe in this yet, the management may need to be on their way out, because data is consuming everyone. And eventually you're going to have an issue where the governor or the secretary of Department of Transportation comes into your agency and says, I need you to answer this question for me now. If you don't have data scientists on your staff that can help you answer that question, you need to tell your secretary that you don't have the right resources to do that. And that could be a way to convince them to change. But good luck with that.
So for agencies that feel they're not equipped for big data, do you see it as a matter of not having the data scientists and expertise, or is it more in the hardware, software?
It's definitely not in the hardware, software. So it's going to be in the expertise. And not every agency is meant to hire data scientists. Not every agency has the budget to do that. It is okay to partner with universities and consultants. Just if you're going to do that, if you don't have the budget internally, make sure you try to form long-term bonds with your consultants and your academic partners so that you don't continually lose knowledge.
All right. Well, thank you so much. Big hand for Michael, everybody. Woo! All right. Thanks, Michael. Okay, so next up, we're going to have a word from our platinum sponsor, Jacobs. Okay, I want to take a second and thank the sponsors. We know these online conferences is a slightly different way to go, and really appreciative of the sponsors. All right, so for our next presentation, we're going to have two speakers. We've got Jose Pagan-Otero, who's a senior traffic engineer at Atkins, North America. Jose has more than 20 years experience, 16 of those in the public sector in traffic engineering, traffic signal design, traffic operations, ITS, lighting, power systems, active hands-on experience with installation, configuring. Jose is also a registered professional engineer in Georgia and Florida. We're also going to have Monika Shepard, who's a customer success executive at Streetlight Data, where she works closely with public sector agencies and businesses in the US and Canada to harness the power of big data to support transportation planning and engineering initiatives. Monika brings more than 17 years of experience with working with governments, nonprofit organizations, and businesses across the world to use data and information technology for key decision making. Now, she's focused her career on advancing cutting edge solutions on a range of sustainable governance challenges. Monika holds a BS degree in design and merchandising from Drexel University. All right, so Jose and Monika, take it away. We're looking forward to it.
Thank you, Michael. Hope you see on my screen. Today we will be talking about how the Atlanta DOT using big data to transportation needs. A leader agenda for today is shown in the screen. Again, I'm from Atkins. Atkins is now part of the SNC Lebanese Engineering, Design, and Project Management sector. We joined forces in 2017, and our Atlanta office is one of the faster growing office in North America. The Renew Atlanta program started back in 2015 with a $250 million bond program, and it followed by a TIS Plus program in 2016. Atkins has been providing Renew Atlanta programs with program management team services in 2016. This has been a successful program based on the numerous awards received. Most recently, the 2020 ACEC Engineering Excellence Award and the 2020 ACEC National Recognition Award. ATL-DOT is the result of the 2019 One Atlanta Strategic Transportation Plan from Mayor Bottoms. It was created to implement the strategies and goals of the plan as a new entity, more agile and efficient to provide the transportation needs of the citizens and visitors of the city of Atlanta. This plan called for action and developed a specific key goals that included a Vision Zero policy to eliminate traffic deaths and also to target transportation needs in a multimodal approach by considering all modes of transportation issues such as bike, pet, transit, and vehicle, and address them in the best possible way. To achieve this, data needs to be available, captured, analyzed, and used to take better informed decisions. Partnering with private sector is one way to access data and the tools to analyze it. Now I will pass the presentation to my co-presenter, Monika. Monika.
Thank you, Jose. Good afternoon, everyone. I work at Streetlight Data, where I work with a variety of folks across the country, including the city of Atlanta, to use big data to help folks make transportation planning and engineering decisions. Streetlight has a platform called Streetlight Insight, which was developed to provide the transportation industry with access to data for virtually every road in the US and Canada. So how do we do this? We use big data. We know big data is powerful and oftentimes used as a buzzword, but data alone is only as powerful as the processing that makes sense of it all. So every month we ingest, index, and process billions of anonymized location records from smartphones and navigation devices in connected cars and trucks. We use advanced machine learning techniques to develop our algorithms. We process all the data algorithmically into transportation-specific metrics. Once the data is processed, it's stored in the cloud, thus reducing storage costs and enabling faster processing speeds. The metrics are then aggregated, contextualized, validated, and cleaned up in order to provide answers to a multitude of transportation-specific questions that transportation and engineering professionals are tasked with answering every day, such as answering corridor studies, origin destination analysis, turning movements, and a variety of other ways in which folks are looking at data. Now, Jose?
Thank you, Monika. Continuing with our presentation, the actual big data is available from location-based devices, vehicle, GPS, and Internet of Things, or IoT. The city has worked in the past with data providers to look for solutions to traffic problems. For example, we look at location-based services for the downtown special event area, traffic congestion, and parking management when we were working with GDOT in preparation for the Super Bowl 53. The city has also looked at various data providers for the use of video analytics and IoT as well. The ATL-DOT has used big data to assist in some of the day-to-day operations, as well as for specific special studies. When we see the graphic here in your left side, about 53% of all analysis using big data have been origin and destination, or a variation of this, followed by segment analysis, looking for speed and volumes data, and zone analysis that look for volumes and turning movement count as well. Some of the others analysis include bicycle detection, pedestrian detection near miss, curb utilization, and congestion dwell times. There are many possibilities for the use of big data. Of course, this is not to substitute existing methodology for collecting data, but to assist in those instances where the data is not available or is limited. And our first case study for today is an intersection on Northwest Atlanta. It's the intersection of Morse Mill and West Wesley. This is a signal line intersection at the residential area. Both Morse Mill and West Wesley are 2-lane roads with no turning lanes. The existing level of service at the intersection is F, and this intersection is about a quarter mile to BC Highway I-75. The purpose of this project was to relieve congestion by increasing capacity and improve safety. Around 70% of all crashes registered at the intersection were rear-end collisions. We presented the concept plan to the public, and we received most of them supporting the project, but also we did receive some strong opposition from the public. Those who opposed brought a valid concern to the city, and their concern was about impacting the neighborhood look and feeling of the current intersection. They said that the traffic that is cutting through the intersection are coming from out of the county, that is not local traffic. And they were very concerned about the impact of the project in the footprint of the intersection. So while we continue the effort to provide with the best design possible and accomplish the scope of work, we consider and evaluate various alternatives. When you see here the graph, this project started back in 2014 with some turning movement counts at 3 intersections, our intersection, and 2 further closer to the intersection, 2 other intersections. Then we hired a consultant in 2016 who adjusted the 2014 TMC and added an additional intersection. In 2018, there was a new TMC done, and basically they added 2 additional intersections, making this a whole network evaluation. And the purpose was to evaluate a possible frontage road that would go parallel to I-75, and in that way reduce the congestion at our intersection, but that proved to be cost prohibitive. Then last year we did yet another turning movement count, a 12-hour count, to look for possibilities or options to reduce the proposed turning lanes length, to reduce the footprint of the proposed project. During that data collection, we drove across the whole area during the AM, midday, and PM peak to make sure that no incident in the interstate or any other route close to the intersection was representing issues for the data collection. And in between this data collection effort at the intersection, we were also looking at how to address that concern from the public regarding the cut-through traffic. So we went to the big data and used an origin and destination to preset geography to perform an analysis. This type of analysis use zip codes, task information, or census block groups data. When you see here, our project is that little red dot, and you see that the darker shaded area are the areas that are providing or contributing most of the traffic cutting through the intersection. We also look at the black circle that represent a 3-mile radius from the intersection. When we look at all the data from 2018, we found out that most of the traffic going through the intersection was from the city of Atlanta. You see there, the orange lines represent the council district boundaries of the city. And almost 50% in the AM and the whole day of the traffic was from within 3 miles from the intersection. So looking closer to the data, we filtered the data and we still see that red region there, and the black dot is our intersection improvement project. We still see that most of the traffic was from within the neighborhood or the city area. Then that way we were able to show the public that yes, there were some out of the county traffic going through the intersection, but most of the traffic was local. That way we were able to flip most of the opposition into support while we continue committing to keep working with the neighborhood on several design options so we can achieve the scope of work while maintaining some of the neighborhood look characteristics. Our case study 2 is very interesting as it has been a challenge since the beginning. We were tasked to look at the possible mid-block crossing installation with a pedestrian treatment at a location on Donald Lee Howell Parkway between Lake Avenue and Francis Place. Some of the challenges we have from the start is that we didn't have any current or historical count at that location. We didn't have even budget for that. It was just a request. Obviously, when the request comes from the commissioner, you need to give it a priority. So we didn't have that resource in hand. We didn't have budget, but the most challenge that we have there, it was that even if we could collect data, we will not have all the data we need because at the time we were doing the analysis, there's nothing happening there, no crosswalk at all. There was no pedestrian volume. The reason is because at the site, there was a school that closed in 2016. And there's a new school that will be a kindergarten to 8th grade as part of the bigger master plan of the Grove area master plan. And when you see that Grove area bigger master plan include not only a new school where we were looking at that pedestrian crossing, but also it will include a YMCA and a theater along with affordable housing in the span of the next 3 years. At least that is the plan. So we also, when looking to for data in this particular case, we identified that there have been multiple safety issues in this corridor, and it's a GDOT corridor. It's a state corridor that we need to coordinate very close with GDOT, seeking their review and approval. And at least there have been 6 different studies and projects completed in the last 3 years or on the way in just a 2-mile stretch. So looking at all these facts, we use big data for the specific crossing location to get AADT, hourly volumes, and speed information. When we were collecting the data or looking through the whole data set that was available, we found out that there's a GDOT short-term counting station about 1,500 feet east of the project, which provided with AADT from 2017 and 2018, and hourly volume and speed data as recent as January 2020. We use big data to capture data from 2019 and calibrated it with GDOT counting station data. We then compare the data to validate it and use it for the analysis. Again, this was just one step in the whole study methodology that we were trying to achieve. Looking real quick at some of the data comparison, we see that both sources were comparable when looking at the AADT from GDOT counting station, specifically for 2018. It registered 22,000 vehicles per day, while our street light data resource was showing a difference of 232 vehicles per day. Looking at the speed data, there was a consistently difference of about 4 miles per hour between our sources. Then we took a look at the hourly volume data. Our big data.
Hey, Jose, I apologize. You're running a little long, though. If you could kind of get near the end.
Yes, I will. Just a minute. When you see the data, all were comparable for AM, midday, and PM peaks. We look also at demographic of the neighborhood closer to the project site to also consider families with children within the school age. So we basically combine all the data we have available from other studies, including pedestrian crossing, MARA, ridership, bikes going through the intersection, and vehicle, and came up with an engineering judgment using the pedestrian crossing forecast of GDOT 2019 PET and Street Guide. And at the end, we were able to justify the crossing. I leave here with 2 quotes about data. One from Jack Acuff that said that data is all, that is all data, a gift from yesterday that you received today to make tomorrow better. And I think in the context of transportation, we have the option to make our transportation system better. Thank you.
All right. Well, fantastic. Thank you very much. Great presentation. But remember, we're going to hold questions now until the end. So we'll dig into the questions after. So next, what we're going to do is a word from our platinum sponsor, 360 Network Solutions. Okay, thank you again to our sponsors. It is greatly appreciated. So our next speaker is Parth Bhavsar, is an assistant professor in the Department of Civil and Environmental Engineering at Kennesaw State University. His research interests include intelligent transportation systems, transportation data analytics, connected and autonomous vehicles, and alternate fuel vehicles. He received his PhD in 2013 and his MS degree in 2006 from Clemson University. He's also has 3 years experience in the private sector in developing transportation engineering and planning solutions, most specifically for microscopic simulation. He's published in peer-reviewed journals such as the Transportation Research Part C, Part D, Transportation and the Environment, the Transportation Research Record, and he's received funding from various agencies such as NSF, the New Jersey Department of Transportation, the New Jersey Department of Community Affairs, and the U.S. Department of Transportation. All right, Parth, the show is all yours.
Thank you. So let me just share my screen. Can you see the screen?
Yeah. That's good.
Okay. So I'm going to talk about mobile data collection system for next generation transportation asset management. that 3 years that I spent was in Atlanta with ITERIS, and I can see a lot of familiar names in attendees. So it's kind of really good. The project, this is a project sponsored by New Jersey DOT, if I think partially funded by US Department of Transportation. New Jersey DOT has something called ITS Resource Center that is led by NGIT in collaboration with a lot of state universities. I was a PI from Rowan at that time. And my focus was particularly this task, that is developing mobile data collection system. I had a really good team from electrical engineering and payment, and I worked with a lot of undergraduate students in this project. I'm still working with some of them. Initially, the vision was to develop affordable and portable system that utilizes existing resources and integrates advanced technologies to collect data. So the overall idea was that can we use some existing DOT vehicle, convert them into a data collection unit for a lot of different type of transportation data collection. This was the affordability comes from my particular vision that I also want to see the same thing happening in developing countries and not only developed countries, because for example, South Carolina DOT can afford a 700,000 vehicle that can collect very detailed three-dimensional data of payment, but a developing country, a small city or a very good city in a developing country may not be able to afford that kind of technology. So that was the main vision. Then we focused more on payment collection, and the DOT requirement was more focused on payments distress detection, specifically potholes and cracks. One of the reasons was that this payment distress detection data are typically collected once every year. The primary reason is that it's very expensive to collect data because of dedicated vehicle, a lot of manpower required, technology, cost of the technology, all that kind of thing. So here the idea was that can we collect some key information to support or complement that high resolution data or 3D data, and then see how payment is behaving over the year. And again, other requirement from usability perspective were minimum human intervention, weather resistant sensors, portability is also important. So the solution we developed was a external payment data collection using a very affordable, readily available camera, and some kind of casing or a device so that it becomes portable, and we can swap over and we can use something called safety service patrol vehicle. These vehicles are similar to hero units in Georgia DOT, and that's what we focus on because they have fixed route, they cover a lot of state routes. So that was the primary target for New Jersey DOT. This is a system architecture that just shows connection, different communication using DSRC, Wi-Fi, LTE. Rowan team focused on developing the sensor, developing AI algorithms, and collecting a lot of data for AI algorithm using LTE. And because the overall goal was that work with NGIT and develop a complete platform that has a DSRC connection. This is how we did first prototype. I just went to Best Buy and bought, this is a Xbox Kinect, and we developed some fiberglass box and connected to our engineers on wheel Rowan van. And we eventually learned that Xbox Kinect is really good when you are moving, but when Xbox Kinect is moving, the RFID and the RF camera and everything, they are not really good in sensing the depth of the roadway and getting good images and everything. So we shift. Meanwhile, we had a mechanical engineering team, mechanical engineering student. They developed this 3D frame by measuring existing state safety service patrol vehicle, how to mount the sensor. This was the second prototype. Again, same fiberglass. But what we did, sometimes this SSP vehicle, they also help, commuters by towing or something. So they wanted this back hitch open. So we develop a device such that, back hitch is still available, and we have a camera that can collect video. This is the laboratory or like row 1 version. This is a 3D printed version. The internals are just very simple Raspberry Pi. We also put IR camera infrared because we wanted to get a payment, surface temperature of the payment. That is really important in terms of predicting life of the payment over time, because right now, if you are in payment, there is just one weather equation that focuses on weather information or information from weather sensor and to predict the life of the payment. And we wanted to see how payment surface is changing over time. This is the deployable version developed by another ECE team. In this, they focus mainly on casing, how to reduce shock absorber, and this is this part is mainly it's to test it immediately, but it's not a permanent solution. This is the permanent solution. Eventually, the idea was to put a plate or some kind of bracket in the back of the safety service petrol vehicle so that we can collect data. So this was the mechanical or physical sensor development part. The problem was not sensor development or putting camera together. The primary issue was when you are in a vehicle and when you are driving 60 to 70 miles per hour and you have a back camera, these are the types of images you get. Sometimes resolution is a very big issue. You get camera, there is also a weather and shadow issue. So these are the problems. We focused on machine learning algorithm existing, and then eventually we develop a framework that focuses on, we call it distributed machine learning, but essentially it's kind of a divide and rule. So first, the sensor that you see in here in Raspberry Pi, we have a small AI code that just detects bad road and good road from the video. And what it does, it uses LTE to send bad road images to the server. So server side, we can run more expensive algorithm that can further classify into cracks and potholes and everything. Now, the problem here is if you look at any algorithm, there is always an error. And when you put output of AI as an input of another AI, the error increases exponentially. So to solve that, we needed some kind of confidence level. So we relied on something called Bayesian deep learning. That is typically it's a Bayesian theory is very well known, and it is very everybody is right now using it. If you search deep learning with Bayesian theory, and this is just a problem formulated with Bayesian theory that instead of events A and B, you have X observation and environment and same prior and posterior distribution. I'll not go into a really lot of math here, but if you are interested in math, I have included this reference. This is a student, actually she's now a doctor, Dr. Dima Dera from Rowan University. This was her dissertation. She did PhD in EC last year. She completed her PhD last year. And this is a paper published by her, and that gives you a really good part of this algorithm, that is math. But if you want to understand very quickly in this 15-minute, this is our standard linear regression. What happens in deep neural network, we have linear regression, and then we are applying in some kind of non-linearity to that equation. And then on top of all these functions, we are applying another level of non-linearity. So this becomes an intermediate output, and this becomes a final output. What happens in Bayesian, instead of getting just 1 point estimate, we are getting we use that output or intermediate output as random variable, some kind of like and we try to get a probability density here. So we get a distribution. So once we have a distribution, we can do two things: a person giving a presentation and how confident the model is in that decision. So we get that confidence, we get that level. So this is again explaining the same thing if you are dealing with images. So this is a image. Computer sees image as a one big matrix. And instead of just 1 point estimate or one big matrix, we are getting distributions at every level. So I'm not going to go in detail, but this is how the output looks like. So instead of just getting the image and telling that, okay, this is a pothole, the model also tells us that pothole, this is the confidence level of the model, the 98% probability that this image has a pothole. So this is what we wanted. Why? Because we wanted this. We wanted to develop that confidence at every level, so we can apply some more algorithms. So what we did, right now we are at the second level, and we can estimate very easily. We can provide information with confidence, crack, potholes, and whether the road is good. We still have to go all the other ways. We have also developed a small visualization platform, and this is just a small video that shows how we use our 3D printed sensor to collect data. I'm the one driving behind the sensor, behind the Rowan University vehicle, and collecting the video. But we drove from Rowan University all the way to Delaware, from South Jersey to Delaware. That is about 25-mile path. And we collected a lot of data. We are still, it's a lot of images. If you think about it, 24-mile, 60 frames per second, and about 30-minute driving one way. So it's a lot of images, but it was able to detect all kind of bad roads. So when the sensor understood bad road, it also detected pavement marking, this kind of pavement patching, everything it was able to detect. Now accuracy was not good, so that's why we focused more on that Bayesian algorithm. And then we also tested with other algorithm. This is the first level result. As you can see, the probability, the accuracy is really good. We didn't stop there because we knew that the weather can play a really big role. So what we did with the images that we had about 4,000 images. We changed the resolution of images. So this is, and then we checked the consistency of different algorithm. These are all different AI algorithm. I'm not going to go in depth, but the algorithm that we had with Bayesian deep learning, that was consistent enough. So then we also went to the second level, and then we selected 4 algorithms to see whether they can detect potholes and cracks. And this is where we are. This is the result I got a week back. Another master's student is working on that in Rowan University. And now we are focusing on essentially removing the external hardware where you need a camera for at least for the US locations, because most of the US vehicle will have this rear view camera, and you can develop a very small sensible hardware that can just take a feed from that camera and send bad road images to server side. And on server side, we will work on something called collecting this information into International Roughness Index, because this is the one that is used by a lot of agencies to convert into meaningful information. So you don't need to worry about all this data collection and everything, but you can look at all roadway in these colors and scale and make the decision as a decision maker. But this will also require integration with other data. Again, the system is at the 2D level right now. So the purpose is to complement that very detailed 3-dimensional data that was collected, that typically all DOT collects once a year. So that's what I have. I think I'm on time.
Perfect. All right. Well, thank you so much. That was a great presentation. Again, we'll take questions at the end, so please go ahead and start entering questions into the question and answers so we can kind of get those later. And now for our, before our next presentation, again, a word from our platinum sponsor, CATT.
How does it feel to experience intelligent mobility? To know you'll reach your destination relaxed and on time? Because someone's there to overcome barriers, to maintain networks and intervene when necessary. Someone who connects people with technology and creates a world full of new possibilities. It feels like CAPTCH.
Okay, and thank you again to our sponsors. All right, and our final speaker is Imran Inamdar. He's a principal solutions consultant at CAPTCH Traffic Comm. He's experienced with a variety of ITS planning, design, engineering, testing, and analysis projects. He's a technical manager for the Colorado C470 CV equipment upgrade, US DOT CV radio testing, and the Central Texas Regional Mobility Authority CAPS Ford CV to X based toll testing project. He provided transportation operations subject matter expertise for the FHWA Cooperative Automated Research Mobility Applications, CARMA effort. He led field testing of DSRC road units in Florida. In addition, he provides CV and traffic management technology solutions support for proposals. He's managed the design and procurement installation of testing for the I-95 Corridor Coalition truck parking system. With that, I think I'm going to hand it on over. We're looking forward to it, Imran.
Right, can everyone hear me?
Sounds good. We can see it.
So, all right. So, thank you all, and Mike for the intro. All 90 of you almost who stayed at the last session of the day to hear my talk. This talk basically Steve Sprofsky from our CV team was supposed to provide, but he apologizes he couldn't be here. So I'll be trying my best to present this in his stead. The presentation is about corridor management in tomorrow's ecosystem. This slide sort of sets the tone and the premise for the rest of the presentation. So basically, what we are seeing here, which aligns with the themes of the far-sighted concept of this entire session, is at the top, you see these traffic management services, which are now connected to the traditional ITS devices, right? You have your sensors, you have your video management systems through CCTV, you have some way of controlling gates and other devices, you have signal systems, your systems like bridge and tunnels that are providing all this data back to the traffic management services. Most of the time that the data that is coming back from these sensors is not very high resolution. It can help with, in some ways, reactive management of incidents rather than proactive. As soon as you add connected vehicles and related data to connected services to the mix, which is very high resolution data that we're dealing with, and you're able to integrate that with multi-agency platforms, what that does is it creates this holistic ecosystem that can then be leveraged to create applications for traveler information services, the sharing of data with partner systems. You can share data with third-party data providers, and also to help with demand management through mobility on demand type services, such as your transit agencies. You can connect payment services into it, and then transportation providers or TNCs such as Uber and Lyft. What we are talking here is not siloed systems that have their own applications. We are talking about a holistic ecosystem that has robust data sets and applications. So for example, a lot of the vehicle to infrastructure type communications can actually lead to support for tolling type applications. I mean, a future where hopefully there will be no gantries, but more and more CV2X type tolling applications, like we've been working on in Texas right now. You could also have connected vehicle freight and commercial vehicle enforcement that can be leveraged by these technologies. So now that I've set the premise, the roadmap for this presentation is I'll talk about the industry trends to start with, then some of the safety issues related to mostly to intersections and the highway urban and highway use cases that the connectivity can actually leverage. We'll also talk about some on the data impact on transportation and moving from some of these pilot type applications to operations. So this is a very well-known map. It was developed by US DOT with support from Volpe. And it shows the connected vehicle deployment locations, both planned and operational across the country. The green dots are planned projects, and the yellow dots or the yellow callouts are the operational projects in the country. As you can see, these projects are now touching almost every state. I think we counted about 30 states that already have some sort of connected vehicle operational system or is planning to put one in. On the East Coast in particular, I mean, Georgia is, of course, at the forefront of some of these implementations. With the IATL CV2X and other implementations related to the ATC MTD. We have some of these applications in Florida. And then there's a lot of work also going on up in Michigan and other areas. Now, a lot of these projects countrywide, except for some, have been more related to pilots, where either it's a SPAT challenge that was being implemented, or some minor applications that are being introduced, or just it was just setting up the infrastructure to test with different kind of in-vehicle devices. The one thing to note here in the statistics, and this is as of August 17, 2020, so this may have changed. That's why the word estimates at the top of the table. Is there are 67 corridors in 30 states. We have about 9,000 or so RSUs that are deployed countrywide. But if you look at the ratio of OBUs that are out there that are active and what is being planned in the future, it's kind of problematic, because if you don't have the in-vehicle devices to be able to capture that data from your roadside infrastructure or even from other vehicles, then you cannot benefit and leverage the data to be able to implement the applications that you want to for the safety and mobility. So we do need more penetration to benefit from the infrastructure. The other issue is that there is this, which is more political and institutional in this sense, is that there is a very large uncertainty about the regulatory environment right now, right? I mean, I don't need to go into the details, but FCC and everything that's going on with DSRC and CV2X. So there is this whole push towards having technology neutral kind of infrastructure that protects the agency, that protects the agency's investment while preparing for the next generation of services. The industry in particular has responded with dual mode devices. So you have roadside units, for example, the one CAPS manufacturers that does both DSRC and V2X. We have OBUs out there that are also dual mode or single mode. And as these 5G services come along and become active in the different regions, especially in the urban areas, they'll start filling some of the market space for safety services that are low latency, and also non-time sensitive type services such as infotainment in your vehicles. So Basically now, what's happening is there is this trend towards using the technology infrastructure which has been deployed and moving towards services that can be leveraged from the technology. So this would mean a lot of agencies are trying to create access for third parties and application developers, for example, who can then provide the applications that are needed to improve the safety and mobility of networks. There is also a lot of focus on edge process sensor data, particularly for detecting and then responding to incidents as fast as possible. For example, wrong way detection is a great example of that, where in the time it takes with the latency to bring that whole information to a centralized system and then activate your signs on the roadways and beacons, with edge processing that can be done much faster and hopefully save lives. There's also a need in the industry now to address region-specific operational services. So for example, you look at a broader region for implementation and multiple modes rather than a siloed kind of a system implementation. And that's taking place in terms of talking to these different innovative firms and startups to figure out the applications, and also stakeholders and users to link different agencies. So the next set of slides talks about some of the safety concerns at intersections. This picture, although it's a little bit misleading, I'm sorry about that, but the data that you see on here is related to the overall picture nationally, right? It's not just intersections. We are looking at private vehicle crashes and fatalities, which is almost 36,500 at this point of time for 2018. We have the second leading cause of death every year involving firefighters, which is road accidents. We have the vulnerable road users who account for 18% of US traffic fatalities, which would include pedestrians and bicycles. Now, we do have, through the connected services, ways to develop applications that can address these issues. So for example, this slide lays out the intersection use cases for mobility and safety. So at an intersection, in the current environment, you have cameras and sensors in the ground for signal detection. You have the traffic signal controllers themselves. So how can you use some of that traditional infrastructure to build platforms that can then capture that data and add some sort of AI or machine learning type technology to it to make it scalable, and also improve it with the safety and the mobility at the intersections. So when you do that, as you have these AI camera analytics in combination with connected vehicle data, you can implement a lot of use cases such as red light warning, emergency vehicle preemption, special vehicle priority, and also pedestrian safety. Like we talked about here, 18% of US traffic fatalities are related to vulnerable road users as of 2017. So how can you build applications that they can use so that vehicles can know that they are either in the intersection or trying to cross the intersection, and save lives that way. There's also the highway use cases part of this for mobility and safety. So these platforms, again, need to be technology neutral and scalable. You want to bring in some of these corridor management type tools along with the data to be able to do predictive analytics for either automated incident management or minimize the effort that an operator has to put in to detect and verify incidents. There are also vehicle-based applications that are V2I related. So you could have warnings on congestion using TIM messages, for example, end of queue warning, slow traffic ahead. You can provide weather information. There are also V2V road safety, like forward collision avoidance, and electronic emergency brake light detection. And then also there is work zone safety and location-based services. How am I doing on time, Mike?
We're at about 13 minutes.
Okay, so the impact of data on transportation cannot be understated, right? So what you're seeing in this graphic is we have the data quality on one side and data coverage or another. And as the data quality and the data coverage goes up, the applications that can use this high resolution data to optimize your network also goes up. So we are kind of here right now in the blue zone with the traditional traffic data management infrastructure. Most of it, as I said earlier, is reactive incident management. For example, incident happens, you know, after the fact, you try to verify it and try to respond to it. The device command and control is also mostly the application of ATMS systems right now. There are some that actually now do automated response planning too, once an incident is inserted into the system. But then as the data quality gets better and better, we are talking about being able to implement integrated corridor management and for example, load balancing and travel demand type strategies in real time. So you could think of something like an incident on a freeway where I live in Virginia, for example, I-66, and can you load balance in real time or near real time using the information that you're getting from the connected infrastructure, for example, and move traffic from the freeway to the roadway with optimization of signals and all of that. So the ultimate thing here is we want to optimize our network so that the supply and demand can be balanced over time. So there is also the push towards leveraging active and dynamic dashboards in order to gain new insights into transportation system operations and utilization. So I keep talking about the reactive basis for incident management. So this sets out an example for maybe a proactive transportation management type system. The pyramid has 3 layers, as you notice. We have the operation, we have the data and insight layer at the bottom. So what we are talking about here is related to pulling in all of the data from the connected services from your traditional ITS infrastructure and using machine learning AI type applications, or it could even be heuristics that look at patterns of the implementation and gain some insights into what's happening in your network, right? Then you get to the operational layer, where the actionable incident management based, where you can make actual decisions based on these data sets. So you could even have systems where we call them decision support systems, for example. That's the major buzzword these days, is you're pulling in the data and these systems are providing you response plans for whatever event you are dealing with. And over time, you can build these systems to be automated enough where you would only need minimal involvement from the operator to be able to implement those plans. And then at the action layer, you have the agency level coordinating, having some situational awareness of what's going on at a multimodal level or a multi-network level, looking at arterials, freeways, transit system, rail, even airports, freight distribution centers. And using all of that information to figure out how the agencies will act and collaborate during these incidents. So now that I've talked about this, we have a couple of examples here as to what CAPS is doing in different parts of the country.
So we are running a little long. Sorry about that. But
Okay, I'll go through this real quick and then we'll be done. In this case, we are integrating RSUs from CAPTCH and then non-CAPTCH vendors. We are actually managing the smart Columbus connected vehicle environment. This includes pedestrian safety, school zone safety, and then also there is a focus on freight. The next one is one of the first CV2X DSRC dual mode implementation of a SPAT corridor in Calgary, Canada. This is related to connected vehicle first responder vehicle priority. And also we are using some corridor management tools to improve safety for first response. As I said, I mean, the focus here is on DSRC and V2X both. So that's my presentation. The one thing is the statistics that were included in this presentation. The sources are all in there on one of the slides. All right, thank you.
fantastic. Thank you very much. Really appreciate your presentation. If anybody has any questions for any of the panelists, please feel free to put them in the question and answer. Go ahead and put your question in there. Before I jump to that, I do want to ask, let me ask a question. This will be to the entire panel and anybody who wishes to answer, but I'd be curious what you see as the greatest challenge to this data collection, data analysis, right? That's been the theme of this center. So what is the greatest challenge that's out there today? And if you could be king for a day, right? People actually did what you say to do. What's your solution, right? How would you address that challenge? Any of the panelists?
Mike, I think one of the bigger challenges is the way we are collecting data, as Michael said in his presentation, regarding having the expertise, the training, because just data, it can be overwhelming to all of us. So we need to look for a way to actually get a good use of that data. And as Michael said, maybe moving from specific ITS devices that are agency owned and start, looking into the big data and partnering with big data sources to help us in that approach.
Yeah, and piggybacking on what Mike had said earlier, right? We in the ITS industry sometimes have this approach where we take a solution and try to look for a problem. A lot of these data-based implementations, especially if you're investing large amounts in the infrastructure, should be very need-based. So as I said, I mean, the data is very factual in this case, where you are looking at all of these intersection use cases, for example, that seem to be the low-hanging fruit in terms of implementing it right now with the data that we have. As the data gets more and more high resolution, we can look at newer and better applications for data, but it needs to be based on the agency needs so that we're addressing the problem rather than trying to take a solution and try to find a problem.
All right, Parth, did you want to jump in there for a second?
Yeah, I just want to add that optimizing existing resources will be also a big part, because payment will last for 10 to 15 years. But how long your camera or any sensor that you have installed, that will last. So you are collecting data, but for what system, why you are collecting data? These are the big questions that decision makers have to look into it.
All right. Well, thank you very much. I appreciate, again, let me thank all the speakers for a fantastic session. I know I learned a lot. I'm hoping the participants did as well. There's been, I think, around 90 at one point we have for participants. Just a couple quick reminder, so at 6 o'clock, and you'll find it in the chat window, there will be the Pictionary, which sounds like a lot of fun. And then tomorrow morning, it picks up again with peripheral vision. I believe that's at 8 a.m. It's a connected vehicle panel. So that looks like a pretty exciting session as well. So again, thank you to all of our speakers. It's been a great set of presentations. Look forward to more ITS Georgia. Thanks, everyone.
Thank you.
Thank you.